Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have m to the power of 9 is equal to 13 to the power of m. Now for this solution, alright, so we're first starting with m to the power of 9 is equal to 13 to the power of m. Now what I'm going to do is I'm going to take the ln on both sides. So now I have ln of m to the power of 9, and now this is equal to ln of 13 to the power of m. Now an important property of logarithms is that, let's say I have log a to the power of b. I can actually move this exponent b to the front of the logarithm. So this would equal b times log a. And this property is known as the power property. And because ln, the natural log, that's also a logarithm. Meaning if I have ln to the power of a to the power of b, this is equal to, I can move my exponent, b times ln a. So in this case, I have ln m to the power of 9, and this is equal to ln 13 to the power of m. So I can think of m as a and 9 as b. So I can move this exponent 9 to the front of the logarithm. So this would be 9 times ln m, which is equal to ln 13 to the power of m. And now I'm going to do the same thing with ln 13 to the power of m. I'm going to move my exponent to the front. So now I have 9 times ln m is equal to m times ln 13. Now what I'm going to do is I'm going to divide both sides by 9m. So then these two would cancel out, and I would be left with ln m over m is equal to, these two would cancel out, so ln 13 over 9. Now, if I have something in the form, now if I have e to the power of ln of x, this is actually equal to x, because the e's and ln's cancel out. So m here, e to the power of ln m, this is equal to m. So now I have ln m over e to the power of ln m is equal to ln 13 over 9. Now I have ln m times e to the power of negative ln m is equal to ln 13 over 9. Because a negative exponent, let's say I have a to the power of negative m, this is equal to 1 over a to the power of m. So now what I'm going to do is I'm going to, from ln m times e to the power of negative ln m, this is equal to ln 13 over 9. Now what I'm going to do is, so now to solve this, what I'm going to use is the Lambert W function. And what the Lambert W function is it states that if I take the w, if I take the w of a times e to the power of a, this is simply equal to a. So I'm going to be using this Lambert W function on our equation here. So our equation is ln times m times e to the power of negative ln m is equal to ln 13 over 9. So now if I use this function, and now before doing that, if I multiply both sides by negative, I get negative ln m is equal to negative ln 13 over 9. So now if I take the Lambert function, I get w of negative ln m times e to the power of negative ln m. And then what I have to do on one side, I have to do on the other. So this is equal to w of negative ln 13 over 9. Now this is equal to negative ln m, which is equal to still w of negative ln 13 over 9. And now if I have something in the form log a to the power of negative 1, this is equal to negative log a, because I can move my exponent here to the front. So this negative I can move to the front. So now I have ln m to the power of negative 1 is equal to w of negative ln 13 over 9. Now if I take e on both sides, I get e to the power of ln m to the power of negative 1 is equal to e to the power of w of negative ln 13 over 9. So then this e and ln cancel out. So now I would be left with m to the power of negative 1 is equal to e to the power of w of negative ln 13 over 9. Now m to the power of negative 1 is the same thing as 1 over m. So I have 1 over m is equal to e to the power of w of negative ln 13 over 9. And now 1 over m is the same thing as, now if I replace these two, I get 1 over e to the power of w of negative ln 13 over 9 is equal to m. So that is our answer. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 2 to the power of 3 minus x equals 565. And what I want to do is I just want to get rid of this base and keep the exponent. So to do that, well, to cancel out an exponent, what we need to do is we need to take the inverse of the exponent. And the inverse of an exponent is a log. So if I take the log of base 2 on both sides, so if I take the log of base 2 on both sides, then these two would actually cancel out because the log is the inverse of the exponent. So if these two cancel out, and on our left-hand side, I would simply have 3 minus x. And on the right-hand side, I would have log base 2 of 565. Now, if I subtract 3 on both sides, because I want to isolate x, these two cancel out, and on my left-hand side, I would have negative x is equal to log base 2 of 565 minus 3. And now if I divide by -1 on both sides, so I could just get positive x, I would get x is equal to negative log base 2 of 565 plus 3. So this is our answer.